With that, I'm so excited to be able to introduce to you our keynote speaker this afternoon. Professor Alexander Pentland, who goes by Sandy, is the director of the MIT Media Lab and the Media Lab Asia in India. He has numerous accolades. I think I don't need to go into all of them. I'm just very excited to introduce him and to have him give the keynote for you this afternoon. Thank you very much.
Okay, I'm glad to be here. So I got my start mapping beaver populations from outer space, which I'll let you think about a little bit. You have to realize I also got my start back in the 1960s, so you have to factor that in. Okay, anyway, so let's see if we can figure out how to make this thing work. Just being blind. Okay, good. So I want to talk about open algorithms, which is a specific program that we have that I think you might be interested in. It's just beginning, supported by the French government and the World Bank. I want to also mention that I'm a founder of Data Pop Alliance, which is an alliance with the Harvard Humanitarian Initiative and Overseas Development Institute to be able to help countries incorporate these sort of new mapping capabilities into their government and into public discussion. Because while we have all this technology and we may have sophisticated understanding of it, a lot of times what you really need is you need the population to understand it and use the product, not just scientists. I also chair the World Economic Forum Big Data and Privacy Councils and the UN Secretary General's Advisory Committee in this, as well as Google, AT&T, and some other places. I got my start in what I'm going to show you about 20 years ago when I started thinking about, well, what happens when there are computers on everybody, right? Because this is back before cell phones and back before wireless, but it was clear that that was going to happen. And so I created a race of cyborgs that had walked around, with computers and ham radio and little head-mounted displays, all sorts of silly things. And we did things like we had fashion show. We joined up with the fashion designers and did fashion shows in Paris and stuff. But out of this came things like Google Glass and a lot of the stuff that we carry around today, the sort of some of the cell phone stuff. You'll notice that this is something that's 20 years ago, more than 20 years ago. And yet some of the devices look a lot like this. Because it was clear from the technology, from things like battery technology and wireless, that these were the form factors that were going to win. But one of the things that was also really clear was that the most important thing was not that. The most important thing is that these devices put off tons of data. Not that they deliver to people. That's all interesting. People are aware. You have maps everywhere you go. But I know where everybody in the world is. Almost, right? And I know what they're interested in as they walk around. And that's very scary from a privacy point of view, but from a mapping point of view, it opens up all sorts of possibilities because now I can have maps of what people are doing. And in the end of the day, the geography is all cool, and that, but I want to know where the people are going. What are their habits? What are the rhythms? What are the demands? What are the changes that happen when you do something? Because that's the thing that drives society, demand, things like that. And we're not used to that. We're used to GIS being static. No, the road is here. Nowadays, of course, we experience whether the road is jammed up or not. And that's concentrating cell phone data and feeding it back to you. And you can imagine doing that on a really large scale. And that's what I do. So when you do that, you begin looking at human behavior at scale, and you come away with very different pictures of humanity than you would by doing laboratory tests or talking to freshmen and having them fill out surveys, which is where, unfortunately, a lot of social science comes from. Here's, for instance, some data. We have access to 6 years of credit card data for 100 million Americans. think about that for like a second. Okay. And this is what almost everybody looks like in terms of your frequency of exploration. So there's places you go, the big circles that are most frequent, and those are things like gas stations and supermarkets and the restaurant around the corner. And the big arrows are the transitions between those. And those patterns, those sort of habitual patterns, are extremely regular. So in fact, if I can watch you in the morning and see the first couple things you do, I can predict with a 90-95% accuracy what you'll be doing at 5 o'clock that day and with who. That's sort of how regular we are. But we also break loose and we do completely unpredictable things. Nobody's been able to do the statistics to predict. And what we're doing is we're exploring our environment. So we go to places very infrequently. And if you think about this for a little bit, you realize that this looks like foraging behavior, something that is exhibited by almost every mammal, almost every vertebrate. You know, you go to the place where the berries are at the same time every day, you get the berries. And then what they do is they also break loose and look else around. Sort of non-economic behavior. It's interesting. What they're doing is building up a map where there are other potential resources in the environment, just in case that berry bush disappears one day, right? And humans show this too. We've looked at this in all sorts of ways, in mobility, in buying behavior, every continent on Earth except Antarctica. And you see it everywhere. You see it in aggregate. And that is, in some ways, the basic rhythm of humanity. Hi, collaborator, data pop. So somebody sent me some pictures because I talk about this, and I think that, you know, they're a little weird, but they're appropriate. You know, we go out and we explore, and then we come back, and we engage with each other, and we trade ideas. And this is a very basic rhythm. It's not unique to humans at all. And I can tell you some amusing stories. I lived with Aborigines for a while. I couldn't go out with the guys because I wasn't that buff. I went out with the women who were carrying the kids, right? I couldn't do that either. And I learned something. I learned that if I was in a society like that, I would starve to death quickly. But this is the sort of thing that happens. What's interesting is if you now map this at large scale. So, for instance, I gave out phones to everybody in a small living community. And I had them fill out forms every day about their health. And what we discovered was that before people will respond that they're sick, they change their behavior. And the way you can see it is looking at this foraging behavior. They stop exploring typically. Other sorts of being sick result in huge amounts of exploring behavior and very little habitual behavior, sort of decay of the habits. So this balance seems to be something that is a signal of health. And in fact, in other animals, it's a marker of how reliable the environment is as a food source or how safe it is. If it's a very dangerous environment, you change your balance, or if the food sources are rare, you change your foraging behavior. Same seems to be true of people. This is data from a mid-sized European country, a second city. So we looked at credit card data, not what people bought, but where they went. And you see this change in foraging behavior in some people, and that is an extremely good indicator that they're going to be in financial trouble within a couple of months. Okay? Somehow they're under stress, financial stress. They change their foraging behavior, and a good fraction of those people actually get in trouble later. Right? And it's better than looking at what they buy or the amount they spend. So this basic pattern shows up all sorts of places. So you can use this to do interesting stuff in terms of mapping. So let me show you an example of doing this at scale. These are people moving around in San Francisco. It's from cell phone data. The big dots are the most popular bars and restaurants. And if you analyze this in terms of co-occurrence, who goes to the same places, you discover that San Francisco is made up of many sub-communities who rarely talk to each other. Now, these are not people who know each other. They just make the same choices about where to go and what to do in terms of food, in terms of entertainment, and so on and so forth. So you can see these subcommunities, and what's really interesting is these subcommunities have different behavioral characteristics. Not only credit risk, not only fashion, but also things like chronic disease susceptibility. One group up there has almost an order of magnitude more likelihood of alcohol poisoning. Another group has almost a factor of 5 greater probability of diabetes. Not for any particular reason, but there's something about the lifestyle choices ensemble that lead to this. And if you go and you analyze this, and this is from a different city, this is that European city, and you look at this co-occurrence, so which populations, which neighborhoods frequent the same stores, work in the same places, and so forth, and you segment the population that way, as opposed to segmenting it by age, gender, income, all the normal education level, what you find is that segmentation by behavior, defined this way, is something like 3 times more powerful than segmentation by demographics. Okay? Let me just repeat that in a different way. Everything you map is probably bogus. Okay? Because, by the way, we make maps of population, we make maps of wealth, we make maps of gender, you name it. That's how we divide up our world, right? And here I'm telling you a much better way to do that is to look at the choices people make to spend their time. And not just a little better, lots better. So we're dividing things up into neighborhoods by choices. Right? And this reflects some basic processes in people, processes like homophily. We tend to stick with people that are similar to us, and social learning. We tend to learn things from each other and adopt the behavior of each other so that we fit in for a whole variety of reasons. And I can go on and on about this if you want, but I won't. Let me just show you another example. So I showed you credit scoring for individuals, people that are going to get in financial trouble. If you take these groups and you ask, well, where are the places that people go? And are there similarities among the places they go? The answer is yes, there are similarities. But one of the really interesting similarities is that for some groups, all the places they go are financially successful. In other words, take the blue guys. The places they go tend to succeed. The little restaurants, the stores, they make money. Take the green guys. Places they go tend to go out of business really fast. In fact, this is a dramatically better way of scoring small businesses than is normal sort of financial indicators. And that's a cheat because normally small businesses don't have very much in the way of financial indicators. You will notice that small businesses are the major employer in our society, in fact, most every society. And the fact that there's no way to credit score them previous to this is a major problem. Well, now I can tell you something about it. But you could also do a little further. You could say, well, gosh, if the stores in one of these groups don't work out very well, what's going on? Maybe we could change behavior, maybe we could change the rules. I don't know. Be interesting to sort of think about. Here's another example, and it's something we're doing in Riyadh. So we got their social unemployment data. So we know where people are unemployed, how long they're unemployed. And we mapped with that, over top of that, telephone data. So telephone data is like, where do the people go? And it's not on an individual basis, so it's not quite perfect. But you can see the following strong trend. Neighborhoods where people don't get jobs quickly, okay, so they just somehow are not able to get jobs very efficiently at all, are also neighborhoods where they can't get around or don't get around in the city very much, right? So they don't explore a lot physically. No, these are like, duh. You know? But it's not something that people had realized. They had tried training the people in those areas better, giving them other sort of incentives, And what we suggested is, well, if the people who can't get jobs can't get around in the city, maybe you should change the buses so that they can get around in the city. And that's what they're doing. Now, Riyadh is a special place because the women can't drive. And a lot of this sort of difficulty in getting jobs stuff, not a lot, not all of it, but a significant chunk of it is that women can't get jobs when they're unemployed. And it's because, of course, they're not able to get around and look for them. Duh. Anyway, you wouldn't see that unless you mapped the transportation over top. Here's another little factoid. So this is something we mapped using Foursquare. So you can, on your mobile phone, check in. Say, here I am, and I'm meeting with my friend Sam. Okay? And lots of people do this. I'm not quite sure why they do this, but they do it. It's just, it's an age thing. But what that means is you can map the density of social interactions, face-to-face social interactions in a city. And so what you can do is you can say, well, what is the density of engagement? Now, this is face-to-face. And in this particular graph, this is in America, and those dots there are cities, 150 cities in America. Almost all of them are secondary cities, or second cities. And what you discover is the density of social tie engagement is directly predictive of GDP per square mile. You can take the same thing in Europe, you get the same relationship with a different slope. And if you look at the slope, that translates into the average commute time and commute distance. So how far you can go times the density of the city determines how many people you interact with to a first order. That's the mean, right? And that determines the GDP per square mile. Pretty interesting. It argues that if you could increase the density or the transportation infrastructure, you could get a more profitable city, or more profitable per square kilometer. This is some data from the UK. The UK has things called councils. They're small neighborhoods, they're administrative units. They keep track of something that is called socioeconomic percentile. It's a linear combination of wealth, life expectancy, crime rate, infant mortality. I'm missing something. No, that's probably it. Because those are all collinear with each other. They all vary together, okay? The bottom is another example of social tie. This happens to be phone calls on landlines, because it's from the mid, like 05, that sort of thing, 06. And it's a simple linear combination of how much do people in a neighborhood talk with each other, plus how much do people talk with folks outside the neighborhood. Engagement and exploration. And it predicts that socioeconomic percentile with an R squared of 0.85. That was in science. Another one was in nature. Okay? So in other words, the phone records are probably as good as the official statistics, because R squared 0.85 is like really good. And we've done the same sort of thing with mobility records, with call patterns from cell phones. Not us, but set up frameworks for other people to do it, given data, had big data contests in places like Cote d'Ivoire, where we were able to map at sort of very fine grain poverty by looking at these patterns and then compare it to official statistics. And you do a really good job. And in Cote d'Ivoire, the thing that's important about this is that the government no longer gets to go in the northern part of the country because of the civil war, right? So it's nice to know where there's poverty, even though you can't get there very easily. So we've done this in a couple different places. This is the global we, done this in a couple of different places. This is something we did in London. So since I sit with the board of Telefonica, and Telefonica owns O2, I convinced them to release average aggregate data for London, and then ODI released crime statistics and other statistics for London around the new year of, what was it, 2 years ago now. And it turns out that you can predict neighborhoods where there will be spikes in crime pretty well. And it's simple. If you look at a neighborhood and it has a particular mixing with other neighborhoods, in other words, so here's a city square, and the people from these other towns typically come there and go back, right? And then suddenly that changes, like the old folks don't come anymore, or the other cities don't mix anymore. That's a place that has some sort of stress going on, okay? That could be good stress. It could be all of a sudden they opened some great thing and young people flooded in and the old people said, I'm not interested in, you know? But about half the time it means crime. And so if you see these sort of big, these are like micro-demographics. See these big micro-demographic changes, we like to joke you should send a social worker and a cop, because you're going to need one of the two, okay? And this has been used in Medellin, and what they tell me is it resulted in almost a 70% drop in violent crime. I don't know if I believe it, but that's what they told me. Right? So what they did is they looked for places where there was a change in these sort of micro-demographics, and they increased the policing in those areas that had these sort of population changes. So it's not about particular people. This is not Minority Report. We have no idea who does the crime, couldn't tell you where they're from. We can tell you that it's probably not young people, because increasing the amount of young people has a very mild effect on crime. That's a common theory. And the idea that you need more people from the neighborhood on the street doesn't seem to work either. It's really mixing from other populations that seems to have the biggest effect on crime. You can predict riots pretty well. Let me tell you about some of the other things that we do. So we use these sort of capabilities for various purposes. So for instance, for Andorra, a little tiny country between Spain and France, right? 80,000 people. It's wonderful to do work there, because you go there, you get in a room with 12 people, and that's the government. It's great. If you get them to say yes, it's done. It's just such a different thing. Anyway, so they happen to own their phone company. So what we got is we got all the phone data. And we looked at all of the tourism events they had. So things like Cirque du Soleil, mountain bike things. And we asked questions about what did it mean for the country. And we could look at a particular event, like the Cirque du Soleil event, and say, well, how many tourist days were extra because you had that? How many of them were new versus people who always go there anyhow? Did they stay in the peripheral part of the city or the country rather than the city? Because that's a problem. Everybody tries to stay in the city, and the people out in the edges don't make enough money and don't like it. Did they have high disposable income or low income? And you can tell that by the type of phone they have and the type of data plan they have, right? Sort of a simple proxy. And did they clog up the roads? And so we looked at this for different things, and this was very useful to them. They now are beginning to understand what they can do to bring tourists in and have the tourists stay and have a good time, whereas before they were not able to do that. And we have these wonderful interactive maps of people coming in. You can do it in real time. It's sort of cool, right? Here's one that's a little speculative, but I think is really interesting. Some friends of mine at Imperial in London said, well, gee, if you can increase social tie density and increase GDP per square kilometer, why don't we ask about the new subway line? And so they built a model of people's mobility. And they said, well, if we put the subway line like that, what's going to happen to all of the GDP in the neighborhoods? And so what you see there is the green stuff is a place where the neighborhoods are going to make more money because they have access to more opportunities. And the red stuff is where some of the density that was the fact that other people had no opportunities, they had to come into the center of the city, was now diminished because people weren't coming all the way in. This is all projection, right? I said, well, guys, if you build that, the edges of the city win, but the center loses. And so they proposed a north-south line, which would compensate for the east-west line. And what's really different here, right, is normally you say, well, let's build some infrastructure. And there's lots of cynical things to say about that. But what's the justification for a new line? Well, decrease congestion. Well, is congestion really bad for the society? Well, I don't know. But here you're saying, if you invest this many $1 billion, you get this many $1 billion back per year. So it's a simple economic argument. You're not talking about quality of life. That's an extra. But so when you're talking to the planning commission or the guys that have to raise taxes or something like that, you can make it in their terms. That's a big difference, believe me. Cheaper energy, helping pregnant women. I'm not going to tell you about that. So over the last many years, we've done things like this in Côte d'Ivoire with Orange, Telefonica in London, Senegal with Orange, Telecom Italia in Italy, all asking similar types of questions. And one of the things that's been key is notions of privacy and security, because the sort of data I'm talking about can be abused in very serious ways. And what we've done is developed a methodology for doing this that we call open algorithms, where you don't actually ever share the raw data. What you do is you take an algorithm like a map-making algorithm, and you move it behind the firewall of the telco or the bank, where it's private data, and you create a map of aggregate features. And you have to be very careful how you do that, because it has to be enough people in the aggregate, and there have to be few enough links between people, between areas, right, that there is no mathematical possibility of re-identifying any particular person. Okay? And it turns out that's not too complicated to do. Okay? But you have to be careful. There's there's little things that are gotchas. So what we've done is create algorithms that do this so that we can create maps like the ones that I've just shown you. And with support from the French government, Orange, World Bank, Paris 21, and being administered by this alliance I have with Patrick over there and Datapop. We're trying to bring this to Senegal, to Bogota, to Beijing, places like that. That's the idea. So it enables aggregate data, public data from private data. And I just want to finish with one thing that I'm always surprised that people don't know. So a couple years ago, the UN, which had its Millennium Development Goals, decided to do it again. We have 15-year goals, right? These are called the Sustainable Development Goals. So it's goals of the United Nations for the year 2030. And they looked back and they said, what did we learn by having the Millennium Development Goals? And one thing they learned is, if you can't measure the goal, it doesn't happen. Oh, okay. But the Sustainable Development Goals are pretty ambitious. They're not just poverty alleviation, they're violence minimization, they're equality, they're environmental sustainability. And in fact, there's 171 metrics that they want to measure to help the UN's Sustainable Development Goals. And so I was on this committee, and we said, gee, you should measure all of those things using satellite data, administrative data, cell phone data, credit card data, the sort of things I've just been showing you. And lo and behold, they wrote it into the platform, and all of the countries in the world voted on it and approved it. And what that means is the UN countries are committed to producing maps of these 171 different features regularly and in a uniform manner worldwide. And they haven't got a clue on how to do it. I just say that. Because it's supposed to be in the hands of the national statistical offices. And the national statistical offices are really good, but they're really good at survey data and particular types of statistics. And they're like way good at that, okay? And then this UN people came along and said, and by the way, you have to measure all these other things. Okay? So they're pulling out their hair. So there's an opportunity for you guys because they need some help and would appreciate it. And it would be good for the world because can you imagine if every country had that level of transparency and accountability in its programs? That would really be transformative. And then you're probably saying, yeah, and this is going to happen, sure. But it also turns out that one of the reasons they vote that in is all the donor countries are saying, we're sort of tired of giving money and we don't know what actually happened with the money. I mean, we don't actually care where it went. We tried to alleviate poverty. Did it work? You can't tell us. Is there less gender inequality? We don't know. Can you measure this in a standard way? And by the way, if you can't, maybe we won't give you as much money in aid, okay, or that loan from the World Bank. And so there's actually a stick attached to these goals too. We'll see how this all works out, but it's not as pie in the sky as it sounds. So anyway, that's it. This is what we do with HHI, and wrote a book on this a little while ago. You could take a look at it. It's $12. Thank you. Back there.
Thank you for the talk. Can you elaborate a little bit more on how you establish causality between
Well, in some cases you don't need causality. If you're just stratifying a population, you say, well, these populations have, it's a way of clustering. Let's take the San Francisco example, right, or this European city. So if I say, well, look, let's cluster them, and lo and behold, we use features we can measure, and then when we go in and do further research, we discover that those are predictive of all sorts of features that we care about, right? Well, then that's just a better way of, you wouldn't think, income is necessarily predicated on normal demographic things, maybe some correlations. But this is just a much more powerful way of predicting. Now, if you talk about the London thing, okay, so well, they're going to spend some money and they hope to get GDP out of it. Is that causal? Because that's actually a strong causal relationship. And I can't point to anything that is an absolute proof of that, okay? But I will sort of first point out is that when you look at any of these development things, you never have that sort of proof. I sort of defy you to show me examples, more than one or two perhaps. But we do have lots of examples where the same relationship holds all over the world. It holds at all income levels. It's justified by the following argument. Because what you're doing is increasing access to opportunities, information about opportunities to people. Now, why doesn't it work over electronic means or TV? And if you look at behavior change, I say, well, what influences behavior change? Turns out that electronic media, mass media are very ineffective at causing people to change behavior. On the other hand, if people you trust and interact with urge you to do something, or just people you interact with do something, that's very likely to cause you to have behavior change. So the strongest channel of influence on behavior is still face-to-face interaction. And that motivates the idea that if you have more diverse interaction, you'll have more access to diverse opportunities. Is that proven? No. There's a lot of economics that's based on that. Is that proven? No. Right? Not in terms of causality. But we all believe it and we act on it because it seems to make sense. What you really need to do here is you need to be able to do some sort of intervention that's balanced. Okay? So you need to be able to change one population that's balanced against another. And we have a couple things ongoing like that, where we've actually have natural experiments where you change the transportation infrastructure of a population where only half the state, for instance, gets this new transportation infrastructure. And you would expect to see, over a period of 3 to 6 years, changes in absolute levels of innovation measured by GDP, patents, stuff like that. So most of it's correlational stuff at the moment, like most of economics, I would claim. And, you know, but it's what we do. Yeah.
I think when we first started all visualizing all this data, there was this sort of idea that just because you made the data available or just because you made a map of it, that you would just automatically get the change that you would see in
Yeah.
the world. And that's not
true. Yeah.
But you seem to have discovered some ways to make it.
There's
to
best
actually get
practice, yeah.
So can you just talk about that for a moment, what you may have learned from putting it into practice?
Well,
What's worked and what hasn't?
people, I mean, there's a couple of things. So the main thing of this collaboration with HHI, from my perspective, and Patrick can say differently, is you need to have engagement with the society that you're talking about what the data means, how they would like to visualize it, what their goals are, and how the visualization relates to the goals. Okay, so there's this process of discussion that it has to be inclusive and so forth. You can't do it from outside. That said, the things that generically work, people have background theories about how the world works. And if you show them data that accords with their background theory, and they say, yeah, that makes sense, let's do it. Okay, so an example is increasing opportunities. Increasing opportunities will make your life better. Is there proof for that? Well, no, actually there isn't, but you probably believe that. And so if I show you something that you can do that will absolutely increase your access to opportunities, you'll probably be motivated to do it. So, you know, what we need to do then is sort of a twofold thing. One is visualize things in terms that people find meaningful for change, where they'll be motivated to do it themselves. And we also need to educate people about theories of change. An example of a theory of change is access to more opportunities is good, right? Because you could imagine that being bad. It's overwhelming, it disrupts, you know, et cetera. And so those are the two sort of things. And we do this at lots of different scales. So, you know, an example of a theory that everybody seems to hold is having people more engaged and more diverse people engaged is good. Okay? Why is it good? Because it harvests more ideas, people are more on board, things like that. And that's actually a really broadly held theory of change, theory of how you should operate. And so if you show people holes in their actual behavior where they're not engaging certain groups, they say, oh, well, that's a problem. And they sort of, without much coaching, try to do something about it. Not always, but you know, most of the time. So this is not like, you know, here's a mathematical proof it works. This is sort of a general principles. You have to have a good theory of change that everybody buys into. Usually it's not something that's even articulated as background, and then you need to visualize actual patterns in terms of those theories of change. And you need to do that in a way that the insight comes from the community, not from people who live in Cambridge.
Okay, with that, we need to get on to the next part of the session. So please go to the two different breakout rooms. In the seminar room, there'll be IKE GPS Spike intro as well as GeoNode, and then the other room, the Belfer case study, will be part ODB and Kobo Toolbox. Please join me in thanking Sandy again for his presentation.